So in this video we're going to look at linear patterns again, but we're going to look at the next type. And so this time we're going to look at linear patterns of the form y equals mx plus c. So they are similar to the ones that we've looked at already, but they're just a little bit different this time. It's just a little bit extra added on. So thinking back to last time, we had this kind of table arrangement with this rectangle with 4 people around it. And we looked at what happens when we join the tables together in 2 ways. And one of the ways that we looked at in the last video was where we really just had the two tables next to each other. Here we're going to look at what happens when we actually join the tables together. Okay, so what happens with the numbers that we can fit around them, and then as a result what happens to the formula that comes out at the end of this. So if that's how we're going to combine the tables, what would it look like if we joined 3 tables together, or indeed 4? So if we join 3 of them together, we would end up with something like that, where we can fit 8 people. If we join them together like that, we're going to get 10 people. Okay, so we've turned them around a little bit so we can fit them on the screen, but essentially we get the same thing no matter which edge we chose to join up there. So how can we have a look at this? So what we want to do is we want to try and think about the numbers and how we represent them in the same way as we did last time. So we're going to put the numbers into a table. Okay, but this time into a mathematical table. So here we can see number of tables on the top, number of people that can sit around them on the bottom. And we construct our formula in the exact same way regardless of what the conditions were. So I need to have a look first and see what it is we are going up in every time. So as I increase my number of tables by 1, what am I going up in terms of number of people? So I'm adding on 2, I'm adding on 2, I'm adding on 2. And so we're thinking back to last time, and the pattern that we know where we add 2's on is the 2 times table. So far, I want to be doing it, number of people equals something times the number of tables. Number of people should be 2 times the number of tables. Only this time when I go to check, if I've got 1 table, 1 times 2 is only going to give me 2 people. 2 times 2 is only going to give me 4. 3 times 2 is only going to give me 6. 4 times 2 similarly only going to give me 8. So I don't have the number that I need to. And so what we can do when this doesn't work out exactly is we can adjust our number at the end to suit. So how do I go, looking at the first table, how do I go from only having 2 people to having 4? I add 2. Looking at the next one, how do I go from 4 to 6? I add 2. Looking at the third column, how do I go from the 6 that I'm currently getting up to 8? I add on 2. The fourth column, 8 to 10. I add on 2. And so what we find is that number of people is equal to 2 times the number of tables, add 2. Okay, so that's the formula that we are working from this time. So it's close to the ones that we looked at last time, but with just this extra bit added on. So how can we simplify that? We don't want to write out all the words. So P equals 2 times T plus 2. And again, in algebra, we can just get rid of the multiply bit that's there. So we could write it as P equals 2T plus 2. So what is that going to mean for the number of people that we can sit at 100 tables? So 100 times 2 is 200, plus 2 should give me 202 people. Okay, and that saves me having to draw out 100 rectangles all joined together and then counting all the dots around the edges. But then we did change the table in the previous video. So what happens when we change the table here? Well, we're still going to try and join them together. Okay, so we've got groups of 2, groups of 3. What is it that happens? How many do we have now? Well, in the first one we've got 10 people. Second one here we've got 14 people around it. Okay, and the only way just now we've got to find those numbers is by just sitting counting all of the dots that represent people. Okay, and we can see that very quickly it's going to start to take a bit of time. So, putting these numbers into our table, we've got 1 table gives us 6 people, 2 tables gives us 10, 3 gives us 14, 4 gives us 18. So once again, I need to have a look and see what is it I'm going up in. So this time, that's my number of tables goes up by 1, the people goes up by 4, goes up by 4, goes up by 4. So far, I want to be able to say the number of people is equal to 4 times the number of tables. But if I just look at the first column here in the table and I do 1 times 4, I only get 4, but I need to have 6. If I look at the second column, I do 2 times 4, I get 8, but I need to have 10. If I do 3 times 4, I get 12, I need to have 14. 14 for 16, I need 18. So how do I make that work? I need to add on 2 to all these numbers that have appeared in white. So to make these numbers at the very bottom here in white match the ones above them, we need to add on 2 to each of them again. So my formula needs to say the number of people is equal to 4 times the number of tables plus 2. How can we tidy that up? P equals 4 times t plus 2, and again P equals 4t plus 2. Finally, we're going to miss in space in our table. So once again, if we've got 100 tables, how many people can we fit around them? So we're going to do 4 times 100, it's 400, plus 2 is 402. And lastly, how can we use the formula? So once we've created it, what can we do with it? Well, we can use it to answer some of the questions that we've looked at already. Essentially, we want to do it so that we don't have to sit and draw out all these little pictures of tables with little people around them or whatever the context is. Right? We want to be able to get to a point where we can chuck the numbers in, crunch the numbers, and get our answer out the end of it. So, how many people can be sat at 15 tables? So I'm using my formula from before. P equals 4 times t plus 2. Next thing I need to do, substitute in my number. So this time I've got a number of tables. So I'm replacing t with 15. So P is equal to 4 times 15 plus 2. 4 15s are 60 plus 2 means that P is equal to 62 people. This time, what if I've got some people? So there are 34 people. How many tables do we need? Again, start with the formula that we've got. So we've got P equals 4 times t plus 2. Substitute in your number. So this time I've got a number of people. So I've got 34 is equal to 4 times t plus 2. I want to find out t this time. So I need to subtract 2 from both sides. So I end up getting 32 is equal to 4 times t. 4 times what is 32? 4 times 8. And so we need 8 tables in this instance.